Okay, so yesterday we started with actually 4.6. We went to the end of the unit. There's a reason for that. I like to review the exponent laws before we get to tougher exponent laws, so that'll just be fresh in your mind. So now we're going to head back to section 4.1, and this is called estimating roots. Okay, and so you're familiar with square roots. Some of you might be familiar with cube roots. We're going to keep working further through those, but this should be a review here, this top part where we're estimating square roots. We did a lot of this in grade 9 where we benchmarked, which is just another word for estimating. So if you start with the number 0 and you ask for the square root of 0, it is 0. Okay, so up here what I've listed is all my perfect squares, and you might remember those from the diagonal on your times table sheets. Okay, so 1 times 1 is 1. In order to get the perfect square of 4, we go 2 times 2. Get the perfect square of 9, we go 3 times 3. Perfect square of 16, 4 times 4, 5, 6, 7, 8, 9, and 10. And last year I would write these perfect squares across the board, and I would just give you random numbers. So for example, I might have said to you, what do you think the square root of 8 might be? And so you'd say to me, well, 8 is between the two perfect squares of 4 and 9, but slightly closer to 9. And we would have drawn that on the chalkboard. And so you would have said to me, well, I know the answer's got to be between 2 and 3, but you can tell me that it's closer to 3. So a good guess would be like 2.8. 2.7 would be a good guess, 2.67542. Okay, and you could check that out on your calculator. We'd do that. We'd have a little bit of a betting game in the classroom, and we'd see who was closest, okay? But anything above 2.5 is somewhat acceptable. Okay, let's try another one, square root of 30. So I know 30 is between the perfect squares of 25 and 36, and it's slightly closer to 25. So therefore I know the answer has to be between 5 and 6, slightly closer to 5. Okay, so it has to be smaller than 5.5. So 5 and 4/10 would be a really good guess. Okay, we're not even going to check it, it's just good guessing. Square root of 52. I know 52 is between the two perfect squares of 49 and 64 and much closer to 49. So I know my answer has to be somewhere between 7 and 8. It should be closer to 7, and so my guess was 7 and 2/10. Okay, you might have guessed 7 and 1/10, 7 and 3/10. Okay, it's got to be less than 7 and 5/10. Okay, so I told you last year in grade 9 that perfect cubes would be coming back to haunt you. So some of you started to memorize them. So right up here is where I've listed my perfect cubes, and you can see they get bigger quicker. That's an exponential thing. So if I give you the perfect cube of 0, you know that the cube root of 0 is 0. 1 is a perfect cube, okay? 1 times 1 times 1 is indeed still 1. 8 is a perfect cube, and its cube root is 2. 27 has a cube root of 3. 64 is 4. 125 is 5. 216 is 6, 343 is 7, 512 is 8, 729 is 9, and 1,000 is 10. Okay, that means that all these numbers, if you multiply them by themselves 3 times, you're going to get that answer there. Those are perfect cubes. Okay, so we can do exactly the same thing benchmarking here with cube roots. If I asked you to benchmark the cube root of 20, you would tell me that 20 is between 8 and 27, and it's easy to see that that one's closer to 27. So therefore I know my answer has to be somewhere between 2 and 3, but it's much closer to 3. So a good guess would be like 2 and 8/10. Let's try it with 30. Okay, I know that the cube root of 30 has to be somewhere between 27 and 64, and again it's much closer to 27. I know my answer has to be between 3 and 4, closer to 3, so a good guess would be, I don't know, 3 and 1/10. That's what I would guess. Okay, let's pick a bigger number. Cube root of 600. Cube root of 600 is going to be somewhere between 512 and 729. Okay, which means that its cube root is somewhere between 8 and 9. And I'm going to send these notes to you too, so you can fill them in if you want. Okay, it's closer to 8, but sort of just slightly. So my guess was just 8 and 4/10. Okay, now we're not going to do that for this unit. I just want to show you your backstory on this. Okay, it's time consuming to find roots by estimating. We're going to be finding 4th roots, 5th roots, etc., and those aren't in your wheelhouse. So we are going to use a calculator. And you can remember at the beginning of the year I asked if you would find the calculator button that looked kind of like this, right? And we practiced with it a little bit, and I told you we'd see it again in this unit, and this is the unit that you're going to see it in. Okay, so you can tell it what root you're going to look for. And when we get to that later on in the notes, I'm going to do a calculator sort of video here, so I can help you out with that. Okay, so let's flip the page of these notes, and I'm going to show you what I mean, okay? Last year, we talked a lot about rational and irrational numbers, and I told you that those were going to be, I'm spelling this wrong, that was going to be the crux for grade 10, 11, and 12, okay? So we're going to take a look at this, and if you punch this into a calculator, the square root of 16, you get 4, okay? 4 is a terminating decimal. It's an exact value. That is going to be a rational number. Now, you should recognize this right now, that the square root of 27 is not a perfect square, okay? And when I punched it into a calculator, okay, I'll show you here. You can see the answer that I got here. I wrote down 5 2/10 here, but if you take a look here, you can see it's 5 and then all these numbers, and the only reason it stops is because, of course, we've talked about this before, it runs out of room on the calculator, right? Okay, this is, remember, a non-terminating, non-repeating decimal. So I approximated this. If I took 5 2/10 and I squared it, I don't get back to 27. I get 27 4/100, okay? So this is an approximation, and because it's a non-terminating, non-repeating decimal, I can't turn it back into a fraction, and that's the definition of an irrational number, something I can't put back into a fraction. Okay, and if you remember from grade 9, you can find the square root of a fraction one of two ways. You can do the numerator and the denominator, or you can plug the whole thing into a calculator using the ABC button. When you do that, you get 4/9 or 4/10 repeating. And remember, when we have a repeating decimal, how we turn that into a fraction, okay, is we know that that ends in the tenths, so we subtract 1 and we get 4/9. That's rational, that's fraction, okay? So that's an exact answer, and this would be a rational number. Now I'm going to stop there, and I'm going to ask you to go through and try these on your calculator, and I'm of course going to post the answer key for sure, okay? So things that I want you to do, I want you to tell me if you get an exact answer on your calculator or if it's an approximate and you rounded it. So you can round it to the tenths, that's a-okay. And then I want you to remember from your youth, okay, whether it's a rational or an irrational. That's going to be important as we press through, okay, in math. Okay. Next page looks like this. So last year in grade 9, we did things like this, okay? This was in our exponent unit, and the whole thing was called a power. This was called the base, and this was called the exponent. That's what we learned in grade 9, okay? And so now we're going to take another step. This is connected. This is the backstory. This whole thing is called a radical now, and the little number here that sometimes people call the root is called the index, and everything that's underneath that root sign is called the radicand. This is going to be important, and that's going to show up on quizzes and tests. Okay, so if I asked you to give me 4 examples of radicals, okay, and you have to use a different index, so I'm going to do that right now. If I asked you to find me the square root of 16, okay, what's the index there? It's a 2. This is the first time you've seen an invisible 2. We talk about invisible ones, but this is an invisible 2, okay? And so now if I said find me the cube root of 27, I've given you another example of a radical. Here's 27 is the radicand. There's my index. The whole thing is a radical. And you can see here I used an index of 2. Here I used an index of 3. It says, and these don't have to work out perfect, okay? You can punch them in on a calculator. 4th root of 16. So here's a different radical, another example, and I've used a different index. And now I'm going to use an index of 5, and I'm going to say find me the 5th root of 32. Okay. Identify the radicand and index for each part in part A. So if I did this one, okay, here is the radicand. It's everything that's underneath the root sign. And if I asked you to tell me what the index was, you'd have to tell me it's that 2. So you can just put an I and an R beside each of those. Now this is just the rest of the assignment today, and I want you just to practice using your calculator. Okay, I'm going to come back and show you this after, but we're at 9 minutes and 25 seconds, which is probably long enough. Okay, congratulations. We're knee deep in Unit 4.